Students, welcome to my YouTube channel. I have created this channel to help students, those who are serious about their IIT JEE preparation and those who want to practice good level of advanced question in physics. Then you can come to this channel frequently and you will find good concept oriented questions. You can take a try first and then you can see the solution. So here I will take numerical questions from various chapters and from various concepts, and then I will also solve these questions. So while solving this question, my intention is not to make you dependent on me on this channel, but my intention is that you can judge how far you have understood a particular concept and you can strengthen your concept accordingly. Today I have come up with a very interesting question from the chapter kinematics. This question may look difficult, but we will use a very common result to solve this question. So I will again suggest my students to first go through the question and give a fair try to solve this question, and then again come back to this video and see whether your solution or approach was correct or not. The question says, a bead is released from point P through an elastic cord PQ placed in a vertical plane. Point P is fixed while point Q can slide on a circular frame placed in the same plane. The center of the circle is at the origin and its radius is 2 meters. Find the coordinates of point Q such that the time taken by the bead to reach Q from P is the minimum. I have given you 4 options also, so you can mark the correct one. The question, if I want to explain it again, it says that this is a P point which is fixed and this is an elastic cord maybe. So the end point, the other end of the cord can slide over this circular ring. You have to find the point Q where the particle released from point Q from point P can release in the shortest time. So you give it a try and again come back to see the solution. Okay, so I think that you have tried this one, and now let's see the solution of this question. But before seeing the solution of this question, let me first share with you a very common result that probably most of you have already done in your classes. So this result says that if this is a vertical ring and I have released a particle from top of that circular ring in different chords. So suppose I have several particles and I have released all of them simultaneously along these different chords. The chords are starting from A and other end of the chords are terminating at the periphery of this circle. Now this result says that if I simultaneously release them, then they will hit the circle also simultaneously at the same time. And the proof is very simple. I have taken any general chord AC, and this chord AB is the diameter. So you can easily calculate the length AB. If I join B to C, then this angle is 90 degree. So ACB is a right angle triangle, and from geometry you can say that AC is equals to AB cos theta, which is 2R cos theta. Now if I draw the free body diagram of this particle which is sliding from A to C, then you can see only normal and weight force acting on it. Further, if you take component of the weight along the chord and perpendicular to it, you will see that along the chord the component is only mg cos theta, and this component is only responsible for the acceleration of this particle. So the acceleration of that particle along this chord is only g cos theta. Now I know the length and I know the acceleration, so I will use the equation of kinematics, which is s equal to ut plus half at square, as u is 0 because we release that particle from rest, from point A. So AC equal to half AT square. Now I can just put their values. 2R cos theta equal to half G cos theta into T square. You can see cos theta gets cancelled out and the time you get is under root of 4R by G. And the most important point about this time is that it is independent of theta. So if you release the particles simultaneously, they will reach the circles simultaneously at the same time. So this result I will use in my solution. Just check the solution in the next slide. Now suppose I have released this particle from P and I have taken, for instance, two different chords PQ and PA, where I have released two particles A and B simultaneously from point P. So the particle 1 will reach that circle at point Q and particle 2 will hit this blue circle at point A. Now according to our result that we have just derived, particle 1 and 2 will hit the blue circle simultaneously, not the black one. Try to understand. This is the circle. From its top I have released particle 1 and 2. So they will hit the blue circle simultaneously. So by the time particle A reaches from P to Q, by the same time particle 2 reaches from P to A. So obviously particle 2 has reached point B, which is on the periphery of this black circle, much earlier than the particle 1 has reached to point Q. So obviously that Q point is not the minimum time point which we want to calculate. So now you can understand that in order to have this minimum time achieved, this Q point should be at the contact point of this blue circle and the black circle. So I think it will be more clear in the next diagram. If you see that, now this point is P and I have released this particle from point P and this particle can reach at this point Q. This is the point Q. Can you see this is the chord, this is the PQ line which will give you the minimum time. Why? Because some other particles, where are the other particles at that instant? When I release all the particles, suppose I have released the particles from different chords. So this is one of the chord, this may be another chord, right? You can see that when this particle reaches from P to Q, this particle reaches at this point only. This particle reaches at this point. All these points will be on the periphery of this blue circle. And only Q point out of all this point is able to touch this black color circle. All the other points, they are still lying on this blue circle and they are away from this black color circle. So obviously this particle will reach this black circle in the minimum time. I hope this logic is clear to all of you. Now it's only a simple mathematical calculation that we will do to find the coordinate of this point. What I have done here, I have taken the radius to be r of this blue circle and this black circle, the radius is given to be 2. If I join the centers of this black circle and the center of this blue circle, then it will be a straight line. Because you can say that this radius, they are normal to the surface. So this is also 90 degree and this is also 90 degree. So it forms a 180 degree, a straight line from O to B. And the length of this straight line OB is 2 plus R. Now, as the coordinates are mentioned of point P, 6, 4, then this vertical distance is obviously 4 and this height, this radius is R. So the left out portion is 4 minus R. And the horizontal segment is 6. So I get a nice right angle triangle OBC, and from here I can say OB square is BC square plus OC square, and from a simple geometry I can find the value of R to be 4, and obviously if R is 4, then BC, which is 4 minus R, that becomes 0. Now if this is 0, so B point actually coincides with the C point, and this angle theta becomes 0. So Q point also lies on this x-axis only, where the x coordinate will be 2 and y coordinate is 0. So that should be the answer of this question. I hope you like the solution, and if you do, don't forget to hit the like button. And if you want more such videos from my channel, then please subscribe the channel. Thank you for being with me.